Example 3 is a nice and interesting problem. Example 3, we want to try to graph this. So we're going to try to find the vertical asymptote, the horizontal asymptote, any x or y intercepts as well. So we're going to try to factor this numerator and denominator, but notice that you can't factor the numerator or denominator. So we know there's going to be a vertical asymptote when x squared plus 1 is equal to 0. So we'll subtract 1, x squared is equal to negative 1, we'll square root, and there is no real number you get out of this, so there actually is no vertical asymptote. Sometimes that will happen for these rational functions. Notice there is no real number that will make this denominator 0, therefore the graph will not have a vertical asymptote. If we try to look for a horizontal asymptote, notice here that the highest power we see is x squared, so I'm going to put that in the bottom and put a 1 there for you so you can see what happens. And then in the top we don't have an x squared, so we're going to have to add a filler, 0x squared. Notice if you add 0x squared to the top, you really haven't changed anything at all. These guys will cancel. It's y is equal to 0. Remember, the equation of a horizontal line is y is equal to a number. So y is equal to 0 here is the equation of the horizontal asymptote. To find the x-intercepts, or x-intercept, all we need to do is set 9x minus 2, that's the numerator, equal to 0. 0 divided by any number is 0, and we know that for the x-intercept, the y value is 0. We'll add 2 here. 9x is equal to 2, divide by 9, and so we have an x-intercept of 2/9, 0. Move this up just a little bit for you. Now our y-intercept. Our y-intercept occurs when x is 0, so this term is gone, this term is gone, and we know now that we have negative 2 over positive 1, and so our y-intercept is 0, negative 2. Alright, let's see if we can graph this. We're going to graph our helper line, our horizontal asymptote. No vertical asymptote for this one. Move this down just a little bit for you. Alright. So that horizontal asymptote was right here. It's just the y-axis. And it's debatable whether you really have to graph this asymptote or not. I mean, as long as you understand it to be the x-axis, then you are fine. I like to put it in there just so I make double sure that I am going, that's going to be my asymptote, my horizontal one. The x-intercept is 2/9, 0. Oh my. Well, better change colors here because this is now the actual graph. So 2/9, 0. Well, that's right there. Alright, and then we've got a 0, negative 2 is going to be the other one. Now this one is going to be a different looking graph, so I'd like to use the graphing calculator to help us here. And we'll go zoom 6 and pause if you need to type this in. It looks kind of weird. It kind of comes down here a little bit, then goes back up there, then comes down this way. It does appear to have an x-intercept just right of the origin and then down a little bit from the origin. There is the y-intercept, so it seems like our points here are appropriate. I think probably it would help though to find these mins and maxes. So let's do that. It's going to really help us to make this graph look like it should. So we're going to go to second calculate. We're going to calculate a maximum first. I'm all the way to the left now. I'm going across the top. We're all the way to the right. Hit enter. And then go back and hit enter where you think that is. So it's approximately at 1.25, 3.6. So here's 1.25, and then 3.6 would be right up here. The side of this graph is going to come up and then kind of slowly drift down like this. Okay. Now we're going to calculate the minimum, see where that's at. And we're not to the left of it. I'm going to go negative 2 is going to be to the left, just barely. You can cursor over if you want and hit enter either way. 0 is definitely to the right, so I'll hit 0 and hit enter. I'm going to guess that it's at negative 1. We'll see how I did. A little bit right of negative 1, so it's about negative 0.8 and then down 5.6. We got negative 0.8 and down 5.6 is going to be about right there. So this graph is going to come down, hit that piece, and then kind of come back this way, just like that. And there you go, a wonderfully interesting rational equation, one that doesn't have any vertical asymptotes. And by the way, a horizontal asymptote can be crossed. Really what we're doing with a horizontal asymptote is we are just finding what the end behavior is going to look like. So it could do a bunch of stuff here in the middle, but it will level out in this case to y is equal to 0.